So welcome to today's class. In this class, we are going to talk about the advantages of iterative over non-iterative approaches for change management. We're going to look at uh, what are actually the advantages of us having iterative and over the non-iterative approaches. Make sure that we manage change in softwares. So going to make a simple comparison of sequential and iterative software development methods. So the non-iterative approaches are the ones that we call sequential approaches. So we have sequential models such as the waterfall model. The waterfall model is one example of a sequential model. Again, the V-shaped model is also another example of a sequential model. Now, our sequential model do not employ the iterative aspect of software development. So the sequential models are normally relying on what we call the intensive periods of collecting and even refining requirements. So if you want to actually design a product, then we are relying on the collecting and the refining of the requirements for that particular product before actually we design the program and before we develop the program. So before the designing and the developing the development of that particular product, we are relying much on the intensive periods of collecting the requirements and also refining the requirements for that particular product. So products that are developed using the sequential models, that is models like the waterfall or V-shaped models, they are actually intended to be complete by the time they are being released to the customers. So the customer will only receive a product that is actually complete. The customer is not going to receive a product before its completion. So when we use these models or this type of a model, we are actually uh, creating softwares that will only be released to customers when they are complete. The software's intention or the developer's intention is to make sure that we are releasing the software to the customer when they are actually complete. Now, if we look at this particular approach, um, there is an assumption that is actually made, and the assumption is that by making sure that we are adhering to the requirements that are actually captured at the onset or during the capturing of the requirements and the refining of the requirements, then the product is going to actually fulfill the wishes of those customers. So we assume that all the requirements that we have captured, all the requirements that we have refined about this particular product, then when we implement all these requirements are going to actually fulfill the wishes of those of the customers. They're going to fulfill the wishes of the customers. Now, if we contrast this with the iterative ways of working, here we are going to put emphasis on making sure that we are delivering to the customers products that are actually less complex. They are not complex. They are products that have simple functionality, but not complete products. So we often deliver these products to the customers so that the customer will be able to test the product, and then the customer is going to give us feedback about the product that we actually release to the customer before we even proceed to make any adjustments on the same product. So we have this technique of iterative that actually encourages us to rely on regular feedback from the customers, to rely on the rapid response to that feedback. We receive feedback from the customer and we rapidly respond to that feedback. to the feedback that we get from the customer. So here we by means of this we are able to actually refine ideas, we are able to revisit designs, we are able to actually revisit development activities, making sure we have the intention of delivering products that are actually better and they reflect what the customer wants. Now we need to look at the system development lifecycle model as a structured approach to information systems. Of course, uh, I have shown you the difference in iterative. The focus is making sure we are delivering a product to the customer that is complete, while in sequential, we make sure we deliver a product that is complete, while in the iterative, we deliver a product that is simple, and then we wait for customer review, and when the customer has reviewed, then we quickly respond to that review to make sure that we provide products that are have high chances of being accepted by the customer. So we have system development life cycle models that are actually used as a structured approach to information systems. So the SDLC, structured approach to information system. So if we look at the software development life cycle, then we see a series of 6 main phases that are actually used to create the hardware systems only. So we had 6 main phases. We have series of 6 main phases that are used to create a hardware system only, then or maybe a software system only, or maybe a combination of both, so that to make sure we are meeting or we are actually exceeding the customers' expectations. So every system development life cycle has 6 main phases. Regardless of what we are actually dealing with, we might be dealing with hardware system only, we might be dealing with a software system only, or we might be dealing with a combination of both hardware and software system. So regardless of what we are dealing with, there are 6 basic phases or 6 basic series that are actually going to be looked at in this structured approach to information systems to make sure that we meet the customers' expectations, or we even exceed the customers' expectations. If we look at the word system broadly, or maybe as a general term, then with reference to Wikipedia, if you look at Wikipedia defines a system as a set of interaction or interdependent components forming an integrated whole. It's a term that can be used in different industries. So it simply means a set of interacting or interdependent components that form an integrated whole. In other words, we are looking at a system as a part of various components, and these components are working depending on one another. So we have different components working together to achieve a specific goal or to achieve a specific function. That is what we call actually a system. So it is a term that can be used in different industries. So when we use this term in software development life cycle, then it is actually a limited term that tends to explain the phases of creating a software component that integrates with other software's components to create the whole system. Now, we have some more specific takes on software development life cycles, which include: one, we have the rapid application development, that is actually test driven development, and an example, we have the waterfall model. Then we have the iterative model that applies extreme programming. Then we have the scaled agile framework. We have the agile model. Under agile model, we focus on Scrum. Then we have the rational unified process. The Big Bang model also that focuses on V model, and that applies the conceptual model. We have the Kaizen model that uses the Kanban model and the spiral model. So we're going to look at the general software development life cycle phases. Here we are putting in mind that each system is actually different from the other system, of course, depending on complexity of the system, depending on what components that are actually required, and depending on what are the expected solutions to this particular business problem or to this particular technological problem, and what are the functionalities. So we need to put in mind, as much as we are looking at a general look of on the system development life cycle phases, we have to put in mind that the systems are going to be different, and the systems are going to be different based on how complex they are. Number two, based on what components are actually required of the system, and what are the expected solutions that are supposed to be obtained from the system, as well as what are the functionalities of the system. So in general, if we look at the system development life cycle phases, we're going to come across 6 phases that are actually the main phases. And the first one is the planning phases, the planning phase, followed by the analysis phase, the design, the implementation, the testing and integration, then finally the maintenance. So let's talk about the system planning. Now, you don't just wake up and start building a system. Before you build a system, you need to sit down, plan, strategize, uh, to create a successful system. You need to actually have a good time to plan. Now, people say that if you fail to plan, you are actually planning to fail. So it is during this particular phase where you decide what exactly you want to do. So what is the problems that you are trying to solve? Look at the problems that you are trying to solve under system planning by making sure you are defining the problems. What are the problems that I am trying to solve? What are the objectives? And also, what are the resources that are actually needed in this problem solving aspect? What are the people, the personnel, the skilled people that are actually needed, and what is the cost? You need to study the ability of actually look if we have an ability of maybe proposing an alternative solution. Yeah, meet with the client, meet with the suppliers, meet with the consultants and employees, study if we can have an ability of proposing an alternative solution. Also, you need to study on how you can make the product better than your competitors. Remember, we are dealing with the business market and we have competitors. So you are creating a product that is actually supposed to be better than the competitor's product, so that you can have it putting your company at a higher scale than all the other companies. So after analyzing the data that you will after analyzing the data I have talked about here, defining the problem and the objectives and also the resources, for example, the personnel and the cost, you have looked at the ability of actually proposing an alternative solution. You have looked at you have studied on how you can make your product better than the competitor's product. Then after doing the planning, in this planning phase, you will come up with 3 choices. You are going to come up with 3 choices that you have to choose one. And the first choice could be you develop a new system, or you improve the current system that you are working on, or number 3, you leave the system as it is. That means you're not going to proceed on altering, you're not altering the system, neither are you creating a new system. You're just working with the system the way it is. So here you are going to do something known as feasibility study or planning. Feasibility study or planning. And here I have mentioned a number of activities that you actually do. And the first one was to define the problem and the scope of the existing system. Then look at, have an overview on the new system and determine the objectives of the new system. Then confirm, is this project feasible? Okay, is it feasible? Like, are we supposed to continue actually working on this project? Then once you have confirmed the feasibility, then you can come up with the project schedule now. Now, in this particular phase, you need to look at things like threats. What are the threats of this project? What are the constraints of this project? How is the integration going to be done? How are we going to take care of the security of the system? You consider all those factors. Now, you're going to come up with a feasibility report for the entire project at the end of this phase. So put in mind that at the end of the system planning phase, you have a feasibility report for that entire project. And this feasibility report is going to be looking at is going to tell us what decision did you settle with. Are we going on with the project? Yes. Now, is the project feasible? Is the project feasible? Yeah. It is going to look at the resources that actually are actually needed. What is the objective of the new system? What are the traits? What are the constraints? What are the integration and the security concerns of this particular system? So after that phase, you come out with a feasibility report for that entire for that entire uh, for that entire project. Now, the second phase is the system analysis. Now, in system analysis, we need to have the end user here. We need to actually determine who is the person, who are the people that are going to use the system. Okay, what are the requirements of these people that are going to use the system? So we need to determine the requirements that the end user requires of the system. You determine them, then document them. Look at what do they expect for the system. How will the system perform according to them? So you're going to do a feasibility study here. Okay, you're going to do another feasibility study here, and this study is going to involve uh, 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 establishing or determining whether um, it's organizational, economically, socially, technological, feasible. You're going to look at the organizational setup. So if we come up with this system, does it support the organization? Is it actually feasible in the organization? You look at the economic aspect of it in terms of resources and funds. You look at the social aspect of it. You look at the technological aspect of it. Do we have enough technologies that we actually need to use to implement this system? It is during this phase that you will be required to make sure that you have strong communication. You have strong communication between you as the developer and actually the client that you're working on the system with. Now, this is going to ensure that you get a clear vision of the final product and how that final product should be functioning. So when you're doing analysis and specification, there are a number of activities that you also need to do. And the first one is you make sure you are gathering, you're analyzing, and you're actually validating the information. You don't just gather information and work on information that is not analyzed and work on information that is not validated. You gather, you analyze, and you validate the information. Then you define the requirements. These are the requirements of the project. Okay? Then define the prototypes for the new system. I talked about prototyping in previous classes. So talk about the prototypes, which is going to be our first prototype for this particular system. So look at the information needs of the end user and also make sure that you are actually enhancing the system goal. So here we're going to use a software requirement specification document, SRS, that is actually going to come out of this phase. So the analysis phase, at the end of this phase, we are going to have the system's requirement specification. And this system requirement specification document is going to specify the software. It's going to show us what software is needed. It's going to show us what the hardware that is needed. It's going to show us the functional requirements. It's going to show us the network requirements of the system that is actually going to be developed. And this document is actually created at the end of this phase. Now, once we are done with planning, we are done with analysis, now we go to system designing. Now, this system designing phase will only come in if you have properly understood the requirements of the customer. You've understood what the customer wants, because this phase is going to actually define or going to describe the elements of the system. It's going to show the components, it is going to show the security levels, it is going to show the modules, the architecture, how the system looks like. It's going to show at the user interfaces, how will the interfaces be looking like. It is going to show what is the type of data that is going to go into and out of the system. Yeah. So we can do a general design of a system using a pen and a piece of paper. But now when we are actually working with, we are working on a complicated or maybe a bigger project, we can actually expand this design and to make sure that we meet the functional and technical requirements, both logically and physically. So there are a number of activities again that are happening in system designing. And the first one is we are including the design of the application. We show how the application will look like. We show how the network is going to look like, how the databases are going to be, how are the user interfaces going to be, how are the system interfaces going to be. Then we are going to transform on the system requirement specification that we actually got in the system analysis, and we are going to convert that particular document into a logical structure now. This logical structure is going to contain the detailed and even the complete set of specifications that can actually be implemented in a programming language. So we're transforming the specification document into a logical structure that can be implemented using a programming language. So here we are also going to create what we call a contingency, or maybe training, maintenance, and even operation plan. How are we going to train the people that are going to use this particular software? How are we going to maintain the software? How are we going to have the software operating? So here again, we are going to review the design that is actually proposed. Yeah, our aim is to ensure that we have the final design that is actually meeting the stated requirements in the specification requirement, in the system specification requirements document. Now, once we have actually reviewed the proposed design and we are satisfied with it, then we can finally prepare a design document, and this design document will be used during the next phases that are actually coming. Now, once we are done with the designing phase, now we can move into the implementation and deployment phase. Now, this phase is going to come after making sure that you have understood the system requirements and the specifications of the system. It is the actual building process of the system. This is where the actual coding is done. We are actually converting the illustrated design of the system into a real system. So in the software development life cycle, we are actually writing the code here. Yeah, if the system needs to use hardware, if the system needs to use hardware, then this implementation could mean now we are configuring the various hard pieces of hardware together. We are actually fine-tuning them to make sure that they're actually meeting some certain requirements and functions of the system. So this phase, when the system is done, then we are ready to actually release this system or installing this system in the customer premises, because the system is ready now to become running. We can actually have the system for use. The system can be live. The system can be productive now. Now, after we have deployed this system, we might be required to train the end users on how to properly use the system, how to help them to get familiar with the system. Now, in this implementation phase, it might take longer. Of course, it depends on how complex the system is and what solutions are actually present in there. So we do the actual coding here, then we deploy the system. Then if there's need to train the users to make them familiar with the system and how the system works. And from there we have the other phase, which is system testing and integration. Now, in system testing and integration here, we are going to take the different components of a system or the different subsystems, and we are going to put them together to form an integrated system, or to form one system. In this particular phase, we are going to actually introduce the system to some various inputs. We are going to supply to it inputs or data, and then we are going to analyze how it gives out its outputs. We are going to look at the behavior of this particular system and the way it is actually functioning at some conditions, testing it with real-time data. We are supplying it with data. We analyze the outcome and we see the behavior of this particular system at given conditions. So testing is actually more and more important, because it ensures that the customer is actually satisfied with what we have come up with. Now, when you're testing, you're not required to have the knowledge. It is not a mandatory for you to have knowledge in coding, or maybe knowledge in hardware configuration, or maybe knowledge in designing. So testing can be done by anybody, regardless of their ability to code or their ability to actually work with hardware and of their ability to to do hardware configuration and their ability to actually design systems. Now, we can perform testing. We can use real users to actually perform testings, or we can have a team that contains of people that are actually specialized, and they can actually uh, perform the testing in a systematic and automated way, making sure that we have the outcomes that are actually coming out, and they are compared to the actual outcomes to make sure that we have the desired outcome. Now, once we are done with the testing, we have the last but not least phase, that is the system maintenance. And in this particular phase, we are going to have periodic maintenance for the system, to make sure that the system is not going to become obsolete. We're going to include, for example, we will be required to replace some old hardware when the hardware runs out. We might continuously be required to evaluate the system performance. How is it working over time? This can also include making latest updates for some components that are actually in the system, to make sure that we have the right standards and the latest technologies that actually can face the security attack threats. Now, in maintenance and support, here it is going to include all the activities. For example, we have phone support, or maybe physical on-site support, where users can get help when they are installing the system. We can implement changes that the software might undergo over a period of time, or maybe implement some new requirements that we have realized the system requires that particular requirement. Then we deploy it at a customer location. Then here we can also handle the residual errors. We can solve any issues that might exist in the system uh, over a longer period of time. Now, maintenance support is going to be needed as long as the system is working. It is going to be needed as long as the system is working, especially for large systems. It is going to be long, and for smaller systems, it's going to be for a short time. Okay, so those are the main 6 phases of the system development life cycle. Remember, I said it is a general look at it, and I said the systems will vary depending on a number of factors, such as the complexity of the system. We looked at the complexity of the system, of the size of the system, the requirements of the system, the objectives of the system will make the systems vary. Now, what are the advantages of using phased life cycle approach? What are the advantages of using phased life cycle approach? What advantages do we have when we are actually using the life cycle approach that goes in phases? Okay. Now, one thing you need to realize is that we have the best of the bug capturing tools, and continuous improvement and fixing of the system is equally important. Yeah, we need to always be improving the system. We need to always be fixing the system when it has issues. Yeah, because if you do that, then you have notifications of some bugs in your system. Now, the first life cycle approach has a number of advantages that I'm actually going to look at. It has a number of advantages, and the first one is that it enhances control and monitoring of large projects. So when we have large projects, because we have the phases like the maintenance phase, then it makes sure it makes sure, or it allows us to make sure that we have control over that particular project. We are able to monitor that project over time because we are into the maintenance phase. Then it is formed of well-detailed steps. Now, the phased life cycle approach, it has steps that are well detailed. That is another advantage. Now, the orderly sequence of development steps and strict controls ensures the adequacy of documentation. Because we have steps that are clearly documented here, then it is going to make sure that we have some strict control. The strict control will actually make sure that we have enough documentation of each particular phase that is used in the other phase. Now, the design reviews also are going to help us to ensure the quality, and we have quality, we have reliability, we have maintainability of this particular solution that is being developed. Now, the progress also and the cost of the system development completion targets here are measurable because you have phases that you're actually working on, you're moving it from one phase to another, then you can actually measure. You can actually measure the progress of the system, you can measure the cost of the system, and you can measure the completion targets. When is the system going to be completed, etc, etc, etc. Now, again, the phased life cycle has its own disadvantages. There are a number of disadvantages, and the first one is that it increases the development time and cost. Here, you're going to spend a lot of time, you're going to spend a lot of money uh, when you follow the phased approach. Number two, it is difficult to estimate the cost of the project. Now, when you're dealing with estimation in terms of cost, then doing estimation for that project is going to be difficult. Now, again, the performance of the system cannot be tested until it is almost fully coded. You cannot test the performance of this system unless you are done with the coding phase. You see, now you cannot test requirements. You're in the requirements phase, you cannot test the requirements. Yeah. Until you are done with the implementation phase, then you can test. Yeah. So until the system is almost fully coded, you cannot test, you can not look at the performance of the system. Now the other disadvantage is that the system details have to be specified up front. You need to have system details specified. Then it increases the amount of documentation as time advances. As we say, it focuses much on making sure that we have enough documents. We have documents that actually are needed, that are come out in each of the phase. So for today's lesson, I'm going to stop there. The next lesson, we're going to start outcome 2. We are going to be evaluating the skills that are needed by a system analyst. So we're going to talk about the role of the system analyst in an information system project, and we go on, and we go on. So have any question, you drop it in the comment section. See you in the next class.